Hi guys, it's Mike at Prime Habitat Builders doing one more segment on heat pumps, and that applies to two different things. That's the heating and air conditioning system in this particular home. This is a net zero house that we've just recently completed. We're just doing the final wrap up on. So heat pumps are used to move heat energy from one place to another. So in a heating application, for example, for this particular house, I won't get into the performance details, but this is a super high performance house. It's almost a passive house level as far as performance goes. Really, really thick walls. Same with the roof. We've got like an R90 roof on this particular house. It's airtight, triple pane, high performance windows. This is an Innotek product, fabulous. So the envelope of this house is really great. And therefore, to heat and cool the house, we need a very small BTUs, the British thermal units, for those of you that are total geeks about heating units. But a small heat pump in this particular home really kind of gets us the primary volume of the whole house for heat. This is only a 9,000 BTU heat pump unit. This is the head unit up on the wall here right now behind me. It's off at the moment, so when it comes on, the little trap door on the bottom opens up. And the compressor is actually on the outside of the building, so there's no connection for piping and stuff, or for ducting, I mean. It's just some Freon tubes that run in and out to move the heat energy from the ambient air outside, because this is an air source heat pump, to the head unit. And once again, this is about a 2,400 square foot house. A 9,000 BTU heat unit here will do the whole entire main floor, but very, very efficient, very quiet unit. But one of the other reasons why I wanted to talk about heat pumps a little bit was because we've kind of optimized this particular house layout, allowed us to do some really cool things with heat pumps. And we're using a Rheem 85-gallon heat pump hot water tank in this particular house to meet all the domestic hot water needs. And because of the location of it, it was right back, almost right behind the kitchen here where we are now. We're actually able to kind of steal the energy or the heat that comes off the back of a fridge. I don't know if you've ever walked up to your fridge, and so depending on the fridge model, some of the vents are down low, some of them are up high, but some of them that have the vents down at the bottom, you feel that it's quite warm coming off the bottom in front of the fridge, and that's because the cool air is being taken from the heat pump that's in the fridge, creating cold for inside the fridge, which of course creates heat on the outside of the fridge. Well, instead of just letting that heat die out here into the kitchen, what we've done is, if you just follow me down the hallway here, we're actually borrowing this heat. There's a heat transfer duct. It's just a pipe at the top of this fridge. This is going to be enclosed with a shroud at the top of this cabinet here in a couple of days once we do the final tune-up. So you can see the vent that goes off the ceiling right now. That's just an 8-inch duct. That's all it is. There's nothing in it. It's just a big 8-inch hole. And that runs, we've taken that pipe straight down through the floor joist system here, and we're actually delivering the warm air that comes off the back of that fridge right to the heat pump at the top of the hot water tank. So this happens to be, again, a Rheem heat pump unit. The heat pump sits on top of the tank itself. And if you look here, there's a silver duct that comes from the ceiling. This is where our pre-warmed air off the back of the fridge, when the fridge is running, just happens to come through here. We capture that extra little bit of heat energy, and it dumps out here into the laundry room. This is a pantry type room area where we want to keep the room a little bit cooler anyway. So we're just kind of redistributing the heat energy that's in the house, makes it far more efficient, and it's just another thing that we can add and optimize in our performance chart. So that's a pretty cool thing. The other thing that you might have noticed, there's a couple of circulation pumps up here. One of the things that we like to do to keep our homes and our mechanical systems really simple and easy, rather than having timers and a bunch of things that are fancy for circulation pumps for on-demand heat, we just have a simple circulation pump that has motion sensors in the kitchen or the bathroom with a timer. So when you're in the kitchen walking around, it tells the heat pump to come on, or the circulation pump to come on, sorry, and just keep the hot water loop in the house warm. And if you're not in those rooms, and if you're not in the kitchen and the bathroom, these circulation pumps just turn off. So it's kind of like having instant hot water on demand, and it's a really inexpensive and efficient way to create a hot water loop. 85-gallon heat pump hot water tank gives us plenty of heat, or plenty of hot water. And this one here is going to get a panel that goes over here to finish it off. But I just wanted to show it to you while things all open. The fan's off at this stage in the game. The pump's not running, but when it doesn't make really much more noise than what a fridge does. So nice, quiet unit, and super efficient because it's a heat pump. So a great way to go, and high performance houses.